Today we are going to discuss about a topic from chapter number 4. The topic is saturated hydrocarbons. Saturated hydrocarbons means the hydrocarbons which contains are unreactive and contains which are unreactive. That means they won't react with anybody until you force them. Unreactive and possess single bond between carbon atoms. Single bond between carbon atoms. So that means it is like this. Say for example, a hydrocarbon like ethane I have taken. Ethane. 2 carbons with a single bond. Carbon valency 4. That means carbon forms 4 bonds. Take this carbon. This carbon already formed 1 bond. So remaining 3 bonds are hydrogens. We write this hydrogens like this. Similarly, on this carbon also we have a single bond. Remaining 3 bonds are hydrogens. So this is a hydrocarbon. Hydrocarbons means which contains carbon and hydrogen only. And it is said to be saturated hydrocarbons. That means in these hydrocarbons, between carbons there is a single bond only. So such hydrocarbons which contains a single bond between carbon atoms is said to be saturated hydrocarbons. In fact, these saturated hydrocarbons are unreactive because they won't react with anybody. Their chemical, almost they don't show any chemical properties, very rarely. That too, if you force it very highly, then they will react. So this is one of the example for saturated hydrocarbons. These are known as alkanes. So now we are going to discuss about different types of alkanes. Different types of alkanes. So now we have, the topic is alkanes. Alkanes. We have so many types of alkanes. In that, particularly in order to remember the formulas of all alkanes, we are going to use general formula. The general formula is CnH2n plus 2. How I am writing this formula, see that carefully. Most of your students will write like this, CnH2n plus 2. So we will keep this 2n plus 2 along with hydrogen. That is not a correct way of representing. So be careful while writing like this. We have to write as a subscript only. So remember that. So next, these are alkanes has general formula of CnH2n plus 2. N value starts from 1, 2, 3, 4, etc. N indicates number of carbons in fact. If you know the carbons, hydrogens numbers also we can write easily. Suppose keep n equals to 1. So substitute n equals to 1. C1. So keep n equals to 1 here. 2 1s are 2. 2 plus 2 4. That means hydrogens are 4. So 1 carbon, 4 hydrogens. 1 carbon, 4 hydrogens. 1 hydrogen, second hydrogen, third hydrogen, fourth hydrogen. So total around carbon 4 bonds has to be there, 4 lines. 1 carbon, so we use the root word meth. All are single bonds only, so the word is methane. Meth is said to be root word. Ane is said to be primary suffix. This is the IUPAC name of the organic compound. IUPAC means International Union of Pure and Applied Chemistry. It is a special branch which gives rules to name any compound. Next, keep n equals to 2. N equals to 2. C2, 2. Keep n equals to 2 here. 2 2s are 4. 4 plus 2, 6. That means hydrogens are 6. Write these numbers as a subscript only. Don't keep along with hydrogens. So here 2 carbons are there. So take 2 carbons. Between them single bond, because it is the category of alkanes which contain single bond only. So 6 hydrogens. On this carbon already 1 bond is there. So remaining 3 bonds. Why 3 bonds? Because around carbon only single line has to be there. Single bond has to be there. That is why. So around carbon 4 single bonds it is. So that is a 4. So 3 hydrogens here, 3 hydrogens here. This I can write that as C. On 1 carbon 3 hydrogens, so H3 I can write like this also. Bond carbon 3 hydrogens. So in this short form also I can write 2 carbons, 2, 3, 6 hydrogens. Its IUPAC name is 2 carbons, root word is eth. Between carbons there is single bond, say ane, ethane. That is IUPAC name. Keep n equals to 3. The formula we used is Cn H2n plus 2. Keep n equals to 3. C3, 3 here. 3 2s are 6. 6 plus 2, 8. C3H8. So 3 carbons, take 3 carbons. It is alkanes category. It is alkanes category. So keep single bonds between carbon atoms. Remember, on every carbon, as it is alkanes, on every carbon 4 lines has to be there separately. Only 1 line is there now. So 4 lines, remaining 3 lines with hydrogens. On this carbon we have 2 lines already, so remaining 2 are hydrogens. On this carbon already 1 line, each line represents 1 bond. So remaining 3 bonds has to be there with 3 hydrogens. So we can write this structure like this: C with 3 hydrogens, bond, this C with 2 hydrogens, again a bond with a carbon with 3 hydrogens. I can write like this. Here 3 carbons are there, so the word is prop. As there is single bond, propane is the word we use. Next, keep n equals to 4. The formula we used is Cn H2n plus 2. Keep n equals to 4. C4, 4. In this place of n I am writing 4. In this place of n keep 4. 4 2s are 8. 8 plus 2 10. C4H10 is a formula. How to draw the structure? 4 carbons, 1, 2, 3, 4. It is alkanes category. So between carbons a single bond has to be there. Take single bond. On this carbon, on every carbon 4 bonds has to be there. 1 bond already is there. So remaining 3 are hydrogens. On this carbon 2 bonds already there. Remaining 2 are hydrogens. On this carbon 2 bonds already are there. So remaining 2 are hydrogens. On this carbon 1 bond already is there. So remaining 3 are hydrogens. So how to write in a simple form? Take this carbon. On this carbon 3 hydrogens, CH3. Bond. On this carbon 2 hydrogens. On this carbon 2 hydrogens. Again a bond. On this carbon 3 hydrogens. We can see very clearly. So 4 carbons totally. So it is root word is but. As it is single bonds between carbons, it is ane, butane. So overall up to here we learned up to n equals to 4. I hope I am clear to everybody.